Hello everybody, let's continue discussing about the mathematical properties of arithmetic mean. Okay, in this video we're going to derive the formula for so-called combined mean. Alright, just like in the previous videos, let n be a positive integer, let x1, x2 up to xn be real numbers, and let n1, n2, np be positive integers such that n1 plus n2 plus np is equal to n. Okay, now it does not need to be first n1 observations. Okay, first n1 observations, but any of, let's divide this data set into p different parts. Okay, p different parts. First part, second part, up to pth part. Okay, in the first part there are n1 observations, not necessarily x1 up to xn1, not necessarily like this, but just any n1 observations. Okay, any n1 observations. And once we have taken these n1 observations, we shall not repeat these values in any of the other groups. Okay, and in the second one, let's take n2 observations, n2 different observations. Each of these observations are different from the ones we've considered here. Okay, now similarly, we will not take these observations again in the another class, so we can group all these values into what you call p different what you call them, p different groups, mutually exclusive groups. Okay, because the observations that we have considered here are not here. All right, and since these are mutually exclusive groups, the total number of elements is n1, n2, np, n1 plus n2 plus np. So there are a total of n observations. So all the data has been incorporated in all of these groups. Okay, so basically this is first, this is second, this is third, this is pth group. Okay, Venn diagram. Okay, and none of the elements are here, so all we group them like this. This is the given condition. Okay, we can group the values like this. Then n1, yeah, then let's say the mean of values in this set or in this group is x1 bar. In this one it is x2 bar. Here it is x3 bar, and similarly in this group it is xp bar. Okay, then we know that arithmetic mean is equal to 1 over n times the sum of observations, so that for this group we have the sum of observations as n x1 bar, and in this group we have the sum of observations as n1 x1 bar, n2 x2 bar, and in this one the sum of observations is n3 x3 bar, and similarly in the pth group the sum of observations is np xp bar. Okay, np xp bar. Then let us see, n1 x1 bar plus n2 x2 bar plus np xp bar. We are adding up all the values. Okay, in this set to get n1 x1 bar. We're adding up all the values in this set to get n2 x2 bar, all the values in this set to get n3 x3 bar, and similarly proceeding similarly, we get np xp bar as the sum of all the values in this set. Now, as per our construction, all the given values are in at least one of these sets. So if we add all of these quantities, we've added all the given values, okay, all the given values like this. So this means summation I runs from 1 to n is equal to n1 x1 bar plus n2 x2 bar plus np xp bar. Okay, now from 1 and 2 we get 1 over n times summation I is equal to 1 to n xi is equal to n1 x1 bar plus n2 x2 bar plus, we can continue like this, get this relation, and this is nothing but the arithmetic mean of given observations. Okay, we've assumed the arithmetic mean of given observations to be x bar. All right, now why is this called combined mean? We are given a data set which has been divided into mutually exclusive classes, and we are combining the means of the values in each of these groups to get the mean, the actual mean of the given observations. Okay, that's why we call it the combined mean. All right, okay, this much for this video.